guys, we're back, and this video is a really short one. We're just going to go through carbon environments on the worksheet. If you're very comfortable with those already, you do not have to watch this. This is more for people that are still struggling with the idea of them. So I've taken Michael's carbon environments and just made a copy of it because he has graciously put in all the molecules here, so I didn't have to do it myself. So let's get started. First molecule is propene. It looks like this. Remember, propene has got 3 carbons with a double bond in them. The double bond can go here or here, it doesn't really matter, it's the same molecule. So let's count up the carbon environments. We have got one here, and one here. Notice CH2 here, CH here, CH3 here. So propene has 3 carbon environments. Let's go down to ethanol. Ethanol's got 2 carbons, CH3, CH2. They're different, so ethanol has got 2 carbon environments. Ethanoic acid, same thing, CH3, and this carbon is different because it's double bonded to an oxygen and bonded to a single oxygen. Sorry, 2. So, cool, 2 carbon environments, meaning 2 peaks on your NMR spectra. Propanoic acid, 1, 2, 3 carbons, all of them are different, CH3, CH2, and your carboxylic acid carbon, so that is 3 carbons. Butanoic acid, this is where a few of you got the question wrong. That's okay, because I can understand why you got it wrong, which is the important thing to help you learn. So CH3 and CH2s, obviously those are different, and with this carbon at the end is different as well. So a lot of you put 3 as the answer here. Not correct, it is 4. The reason why it's 4 is because this carbon is connected to 2 hydrogens and it's bonding to 2 other carbons. Okay? How this carbon is bonding to 2 hydrogens, it's bonding to 2 other carbons, but the carbon that it's bonding to is different from this carbon. What's a good way of putting this? This carbon here is slightly positive because of these electron withdrawing groups here. Okay? So this carbon's slightly positive, meaning electrons are going to be taken from this carbon and put onto this one. Okay, I wonder if I can edit this picture. No, I can't, that's fine. So, this carbon's actually different from this carbon, because this carbon's just next to 2 regular carbons, or this carbon's next to a positive one and a normal one. Okay? Propanol, all 3 are different because CH3s, CH2s, and this one. Got 3. Propanol chloride, 1, 2, 3. And so you may just saying, aren't these all the same? Like prop 3, but 4, prop 3, ethanoic acid, yep, 2. And so if we go down here, ethanamide, that's 2 as well, because CH3s and your carbons double bonded to oxygens, this is different. But now we get to these ones, propan 2amine. This carbon in the middle is different because it's bonded to a nitrogen, but these CH3s are identical to each other because of the molecule's symmetry. So while it has 3 carbons, because the longest carbon chain is 3, because prop, we only have 2 carbon environments here. So your NMR spectra will only have 2 peaks on it. Same thing's happening here. These 2 carbons, the CH3s at the end, are identical to each other, meaning we only have 2 carbon environments despite the molecule having 3 carbons in them. Okay? Alright, that is all for this video. You all have your internal SciPads because you keep those in your bags, you don't keep them in the classroom. Meaning I'm going to set some work out of the internal SciPads for today's, and this work's going to be it's going to be for today, and it's a few pages so you can have the holidays to do it as well. Cool, thank you guys.